Hi class. In this video, I'm going to be talking about solving two-steps equations again, and this time we're going to focus on equations in the form of x plus a divided by b equals to c, and x minus a divided by b equals to c. So an example of that would be here, where I have x plus 5 divided by 4 equals to 3. So again, we want to isolate for x, and we want to use reverse BEDMAS for that. So reverse BEDMAS will be called SAMDEV. So for SAMDEV, we want to undo subtraction and addition first. Then we want to undo multiplication and division. Then we undo exponents. And finally, we undo brackets. By undo, I mean we want to do the opposite operation of whatever is happening, such that we get x by itself. So normally here right now I have x is being added, 5 is being added to x, and x is being divided by 4. So normally, according to SAMDEV, I would take away 5 from both sides here. However, there is a unspoken rule when you have equations in this form. The unspoken rule is that you actually have invisible brackets on the top here. So there are invisible brackets here. And because of these invisible brackets, it is implied that I don't undo subtraction and addition first because it's inside of my bracket. Since it's inside of my brackets, I actually try to undo whatever is inside of the brackets last. So subtraction addition, I wouldn't be able to see it because it's inside the bracket. So next I would focus on multiplication and division. In this case, since x plus 5 is being divided by 4, what I would do is do the opposite and times both sides by 4. So if I do that, I'm now going to get, if times 4 and I'm dividing by 4, I just get 4 divided by 4, which is just 1 divided by 1, which would just be 1, right? In front of here. So I just have x plus 5 on the left side now. Now on the right side, I get 3 times 4, which is going to be 12. So now I have x plus 5 equals to 12. Now I can undo my addition by doing the opposite and taking away 5 from both sides. So in this case, I now have x on one side. On the other side, I have 12 minus 5, which is 7. So x equals to 7. Now, how do I know if I'm correct? Well, I can always check my work, right? So to check my work, I replace x with 7. So now instead of x plus 5, I have 7 plus 5 divided by 4 equals to 3. But does that actually equal to 3? Let's find out. 7 plus 5 is going to be 12. And 12 divided by 4. Does 12 divided by 4 get me 3? Yes. So that means x equals to 7 is the correct answer. Okay, now for this next example, I have x minus 4 divided by 3 equals to 2. So again, there are invisible brackets here. Because of that, I don't undo my subtraction here with addition because my brackets is my last step that I have to undo with reverse BEDMAS. So I'm going to undo the division first by doing the opposite. Since I'm dividing by 3, I'm now going to multiply by 3 on both sides. So now on one side, I'm just going to get x minus 4. On the other side, I have 2 times 3, which is going to be 6. Now I have x minus 4 equals to 6. I'm going to undo the minus 4 by adding 4 to both sides. So now I just have x on the left side. On the right side, I have 6 plus 4, which is going to be 10. So x equals to 10. Okay, I will show you another way to solve this question as well. So I'm going to write here or. Just as an aside, you can tell me what looks easier. Recall that if I had, let's say, a fraction like this, 2 plus 3 divided by 7, how I ended up getting that was 2 over 7 plus 3 over 7. Now, 2 over 7 plus 3 over 7, because the denominator is the same, I am allowed to just keep it the same and add the top numbers. So in this case, x minus 4 divided by 3 actually can also be written as x divided by 3 minus 4 divided by 3, which equals to 2. So if you have it in this form now, what you actually could do is, since there's no invisible brackets anymore, undo the subtraction first by adding 4 over 3 to both sides. Right? So I'm going to add 4 over 3 to both sides. Now on this side, I'm just going to have x divided by 3 left. On the right side, I'm going to have 2 plus 4 over 3. Now, if you recall, 2, if I let the denominator be 3, I can let the top number be 6. So this is actually 6 over 3. So 6 over 3 plus 4 over 3, right? 6 over 3 plus 4 over 3 would just be 6 plus 4 over 3, which is just 10 over 3. So I actually have x divided by 3 equals to 10 over 3. Now, because x is dividing by 3, my next step would be to multiply both sides by 3. And if I do that, all I have left is x on the left side, and the right side I have, well, 10 over 3 times 3. Remember, for multiplying fractions, 3 can also be written as 3 over 1. So in this case, I multiply top number by top number, bottom by bottom. I end up getting 30 over 3, which is just equal to 10. So that means x equals to 10. So notice how I got the same answer as what I on the bottom as I have on the top. However, the top is way easier to solve for if we just assume there are invisible brackets here and then apply our SAMDEV rule instead of breaking this, I guess I can call it like fraction apart. Okay, let's go over our last example. Here I have x plus 8 divided by 5 equals to 4. So again, there are invisible brackets here. Because of that, I solve for the plus 8 last because it's inside the bracket. So now I'm going to do the opposite of dividing by 5. I'm going to undo that by multiplying by 5 on both sides. Okay, now I just have x plus 8 on the left side. On the right side, I have 4 times 5, which is 20. Now I want x by itself. X is adding to 8, so I want to get x by itself by subtracting 8 from both sides. That now leaves me with x on the left side. On the right side, I have 20 minus 8, which is going to be 12. So x equals to 12.